In Missoula, Montana, Ryan Palma runs a sustainable lumber company, which sells a high-end, handcrafted flooring, doors, and paneling made from blue-stained ponderosa pines, many 100 to 400 years old. He harvests only trees that have been dead at least 2 years, so that all the beetles are gone, and he dries the wood slowly in a large kiln that's fueled by scrap beetle kill. The stain kicks the wood into a lower grade, says Palma. So sawmills don't want it, but a luxury market is growing, mostly out of state. Musician Jack Johnson has a beetle kill guitar. Al Gore owns a blue-stained ukulele. The blue hue is caused by a fungus, one of two that the mountain pine beetle carts around in a fungal suitcase in its exoskeleton. The beetles also carry yeast, and for years 6 used one variety to home brew a beer she called six-legged ale. When beetles bore into a tree, the fungi slip out of the suitcases and grow alongside the larvae, providing them with nitrogen-rich food. The beetles can't survive on the wood, says 6. It's pretty much junk food. The fungi act like nutritional supplements, and that's what allows the beetles to do what they do. One of the two fungi thrives in cool temperatures. The other likes things warm. Their populations in the beetles shift with temperature. 6's lab created models to see what might happen to the fungi as the planet warms. If we warm things up a degree, she says, what appears to be a very symbiotic, fine-tuned system begins to fall apart. Over the course of a century, the cool-loving fungus disappears. That's a small source of hope. The cool-loving fungus is the superior source of nitrogen. It enables the beetles to produce 1/3 more offspring, which can make all the difference to a forest. 6 says the cool fungus is already vanishing in warmer parts of Montana. In some low-elevation ponderosa forests, less than 1% of the beetles now carry it. Global warming has been letting the beetle thrive, but as it continues, it could cut the epidemic short. Or maybe not. The genome work has shown that mountain pine beetles are as genetically variable as humans are. The genetic variability is a source of adaptability. So is beetle behavior. For whatever reason, beetles at the northern end of the Rocky Mountains in Canada seem better able to deal with cold temperatures than beetles in the United States. No one really knows yet how the species, or the forests themselves, will respond to a warmer future. In the Jemez Mountains of northern New Mexico, a few miles west of Bandelier National Monument, Craig Allen stands on an outcrop of flat, craggy rocks and stares into Cochiti Canyon. All over the world, drought-stressed forests are being tipped toward death by rising temperatures. The slanting autumn sun carves shadows on the slopes. It's a spectacular vista, except for one thing. Virtually every tree in sight is dead. A first ecologist with the U.S. Geological Survey, Alan has been based at Bandelier and taking in this view for nearly 30 years, and his heartbreak is palpable. Mountain pine beetles weren't a factor here. Bandelier is at the southern end of their range, but other species of bark beetle have killed many trees. So has a trio of huge wildfires, the last in 2011. In all, about 2/3 of the trees in Bandelier have died since 1996. Some forests vanished completely, killed by one fire and consumed by the next, leaving open meadows where thick stands of trees recently stood. What happened in the Jemez Mountains, Allen says, is an extreme example of an emerging global phenomenon. What Diana 6 calls tipping ecosystems. In New Mexico, beetles and fires tipped a system that was already stressed by drought. And all over the world, as in New Mexico, according to studies done by Allen and other researchers, drought-stressed forests are being tipped toward death by a global amplifier, rising temperatures.